Hello, my name is Garrett from HydraTest, and welcome to our last demo on the HydraTest HT Sol machine for the 2020 ATRA show. So I am the technical support and technical sales lead for North America, and today we're going to go over our solenoid testing machine for those of you unfamiliar with it. So if you're in the market for a solenoid machine, if you're looking at doing solenoid testing, reclaiming of solenoids to help save some money for the units that you're building, whether you're a shop or even a reman, this is the machine that's going to help you with that. So I'm going to just kind of briefly go over the machine. We'll run through, do a demonstration of testing the solenoid in here. I've got a Nissan RA5 solenoid to kind of give an idea of what the machine is all about and what it can do and what makes it unique. So let's just start out. We're going to go over kind of the operator panel here and point out some of the really unique and nice features this machine has. My history includes time at working for Axiline, Zoom Technology, Answermatic, and PowerTest. So I've been around test equipment for most of my career. I've worked with other solenoid testing machines. If any of you are familiar with the Solex 2000, very familiar with that. And I really like this machine and kind of taking this to the modern age of solenoid testing. So let's start out here. Kind of our operator panel up here, we got a couple switches here. Mains turns our power on, pump turns our pump on. We got an e-stop button on the side there, so in case anything happened you need to shut the machine off. But we're going to kind of look over here now. These are our 2 panel meters that monitor our temperature in the machine. And that's one of the things that's really done well on this machine. You know, when you're testing solenoids, it's really important to always have the same conditions on the solenoid that you're testing versus the one you're comparing against for your data. And one of the things that they focus on a lot with this machine is we monitor and try and hold that test temperature where we want it. So what this has is an insulated reservoir in that our ATF goes into. It's insulated, it's kind of isolated, it's not part of any of the work sump. All the oil that is used for testing the solenoid drains into that, and we have a temperature controller here, so this monitors what the temperature is. Right now it's 94 degrees, but I can set this, and that's 94 degrees Fahrenheit. I can set this to the temperature I want to maintain that tank at. There's a heater in there, and it'll sit there and monitor and maintain that temperature. Also, we have a second panel meter here that monitors our temperature of the test oil after it's gone through the hydraulics on the machine, through the pump and all the plumbing, and right before it comes out and goes into the hose that feeds the solenoid. Because that's great that we have our test oil at a temperature in the tank, but I really want to make sure that the test oil that's going into the solenoid, what temperature that is. So this is the one you're going to want to watch. When you do your solenoid test, you're going to want to run through a few cycles until you get that hot oil from the tank up to the solenoid, and we're sure that we're putting that hot oil into the solenoid. It hasn't cooled down going through any of the plumbing or anything like that. So that's one of the really unique features on this machine that I think is very important for solenoid testing. A couple other buttons we have here. We have this as a deadhead switch. What this does when we press this deadheads the pump and doesn't allow any of that pressure to get out to the solenoid. So just as our temperature is so important when we're testing to be consistent with the same temperature every time, the same thing with our pressure. So what we want to do is we deadhead this pump so we don't have any fluid going anywhere else, and we can dial in our pressure exactly to whatever that test pressure we want to set at is. So let's just say, on this example, I'm going to do 120 psi. Once I clear that, now I allow that fluid to flow out to the solenoid. If I have some leakage in the solenoid, I'm going to see that test pressure I set drop. And the more leakage I have, the more it's going to drop. So, you know, most solenoids will have maybe a little bit of leakage. We might see it drop a few psi. But if we had like a 10 or a 15 or even a 20 psi drop, we would know immediately that we have something going on with that solenoid that's not correct. And we may not even have to run the test at all. We just know right from that we have a bad solenoid. So again, that's kind of one. The other feature on here that's just so important when we're testing is we want to have the same test every time we do it. So we can monitor and set our temperature exactly where we want it. We can monitor and set our pressure exactly the same every time. Because if we don't do the same test every time, we're going to get different results. The same test should give us the same results for the same performance on a solenoid. If that same test gives us a different result, then there's something going on with the solenoid. And the whole goal of this machine is to pick out the good solenoids that can be reused again with confidence that's going to go through the whole life of that transmission after you've rebuilt it from the ones that won't. We want to separate those out and be sure the ones we're putting back in are 100% good. So, let's see here. Oh, works up on this machine. So just open the door. We have a nice heavy door, easy access in terms of just viewing capability in here. There's some latches on the side that kind of tighten up to hold that so it doesn't fall down on you. Works up on this machine. I told you, some of you that I mentioned that I'd worked at Answermatic Zoom Technology in the past. One of the biggest complaints I remember back in the day we had on that machine is it was tiny and it felt very claustrophobic trying to get in at that machine and work on testing solenoids in there. You kind of had underneath the lip of it, and it was a small machine. So this machine, it's a little bit bigger. The work sump is laid out very well. It's a very nice, large work sump, easy to get at. You don't have to reach underneath anything. The block sits in here this way, drops down on a couple of standoffs, and then our plumbing is done really intelligently. We have a hose that connects on this side as our input pressure going into the test block, our output pressure from the test block up here, plenty of room. There is also a valve in here, and it kind of looks like one of those things you see in a CNC machine where you can move it to a spot and put coolant on, whatever is you're machining. It's kind of the same thing, but what we do in here is we take some of that hot oil out of the tank that's coming out of the pump, and we run it through there, and you can dial this up and actually puts that hot oil onto the solenoid. So part of that whole temperature control is we're monitoring and getting hot oil into the solenoid. We can also take that same hot oil, because we have plenty of volume on this pump, and we can dump that hot oil onto the solenoid to get that solenoid up to temperature and maintain that test temperature. So very important and done very, very well on this machine. Also, I should mention too, on this machine, this pressure on this machine will go up to 300, or a little more than 350 psi. So older machines didn't go up that high of pressure. They had plastic tubing on the inside. This has all hydraulic rated hoses, metal tubing on there, and it goes up to a very high pressure for testing some of the later model solenoids. Very, very important. So that's another feature on this machine. Our control system on here, so the machine usually comes with a laptop. That's standard, comes with a laptop. If you wanted the desktop, you wanted a bigger display, we can quote that out. That'd be a little bit of an upcharge. And it comes loaded on with our control software, and what our control software does, it controls that solenoid as well as monitors and records all of the pressure and current measurements happening while you're doing that test. We have a script writer in here. There's some scripts already in here. Those are the sequences it goes through, but with the script writer you can go in and create your own scripts, because you have access to kind of change all the different parameters in here for how you're testing. You can change and set, what frequency I want that solenoid at. I can set the duty cycle range, which reflects on how much current, the solenoid is gonna draw, from 0 to a certain amount of current and back down. I can set the different time I want that ramp up to happen, how long I want to hold it somewhere, how long I want to ramp it down. I can set how many different times I want to do that. So if I want to have a ramp that's really slow and I bring that solenoid up to max current and back down, and one that's quick and one that's maybe real quick, I can write that all in that script writer. So we do show you how to do that. We're going to be doing some videos in depth to put on our YouTube channel for anybody that has these or are getting that, so you can go back and review that. You don't have to always contact us if you have a question. We'll have that all done on there. But we give you all access to be able to do all that different stuff. Write your own scripts. If you get a solenoid that you have certain problems with at a certain spot, you can kind of isolate that in a special script that you write just for that. So what I'm going to do now is I'm going to go through and kind of run the solenoid. I'm going to have it zoomed out. I'll be talking a little bit, and then afterwards I'm going to zoom the camera in just on the monitor here, and we'll run it again so you can kind of see on the screen. So we'll do that twice. Again, if there's any questions anybody has that's watching this, go ahead and type them in on that chat box, and I'll kind of peek at it and see if I see a question, I'll answer it as we're going. So I'm going to turn on the pump. And you can kind of see there's pressure over here. This is my input pressure to the solenoid coming off the pump, and this is the output pressure from the solenoid. So there's a couple different things I can do in the software. The first thing I'm going to do is do a solenoid test. So if I click on that, what it does is it applies current to the solenoid, and we're looking to see, or I should say applies the voltage to the solenoid, and we're looking to see what the current it gets back is. I'm sitting at 50% duty cycle. I have an expected value of about 0.93, and I'm measuring about 0.99, 0.98 right now. So if I had an open circuit or a short circuit or a solenoid issue where it's drawing half of that current, that would show up right away, and I'd probably want to stop right there, because there's no point testing the solenoid if my current value doesn't match what it should be. Exit out of there. So now what I'm going to do is I'm going to go to the test scenario. This is a script that I already wrote. I have a recorded that as my master data. So now you can kind of pretend that this is a different solenoid I'm putting in, and now I want to compare the data I get from this solenoid with that last one when I run that same script. So once I click test scenario, I click start. Now the first thing it's going to do is going to prompt me, and this is all these prompts are what you type in that script, so you can put any wording you want in those prompts. If you're in a different country, you want to type that in Spanish or French or anything like that. You don't have to be stuck using English. I have these, as I mentioned before, set to Fahrenheit. These normally come outside the U.S. They come set to Celsius. These didn't change. So the first thing it's telling me to do is set my test pressure to 120 psi. So I'm going to hit my deadhead switch. I'm going to dial this to 120 psi. There we go. Now I'm going to clear it. Now my pressure drops about 2 to 3 psi, so that's normal on this solenoid. But if that drops at 10 psi or 15 psi, I'd be looking interesting, okay, where's that pressure going? Because this solenoid obviously isn't holding back that pressure. I'm going to hit continue, and what it's going to do after I hit continue, it's going to ramp that current up, hold it, and ramp it back down. My ramp is 8 seconds, up and down, and then it's going to hold it for 1 second in the center. So there, my current's going to ramp up. Now it's ramping. You can see my pressure is increasing as it's ramping that duty cycle. Now it's going to hold it for 1 second. Now it's going to ramp that duty cycle and that current back down. And then when it gets done, what it's going to do is going to pop up a graph. And what this graph is my master data that I had pre-recorded versus the data I just got off of the solenoid. So I can visually and graphically see what happened, right? My input pressure, my output pressure. I can turn on the current that I measured from the solenoid. I can see that on the screen as well. And again, I'm going to do this in a minute again so you can zoom in on the screen so you can see that. So I don't know if you can see that, but I have all three. I have my input pressure in gray, I have my output pressure in red, and I have my current in blue. And so now I can visually look at this and I can see, do they lay over the top of each other? Do they not lay over the top of each other? Is there a spot where it drags and all of a sudden jumps up? Is there any funny spots or maybe a wear spot inside that solenoid? So I can identify those bad solenoids. That's what I'm looking for. I'm looking for bad solenoids. And verifying or checking that the ones that I believe are good are in fact good. Exit out of there, and I'll show you one other feature. Another feature that's very useful on this machine is an auto mode. So in that script, what I can do is I can set up a loop, where I can say go through these 3, 4, 5, or however many steps and loop it over and over and over again. So when I go into the auto mode, what it's going to do is going to find that loop, and it's going to just start looping it. So what I have set up in here is just looping that ramp up, down, and back, or ramp up, hold down, ramp up, hold down, doing that over and over and over again. I can bring up my live view, which is my graph, and so now I can actually see my master data, and then I'm tracing over it with the data I'm recording right now as it's running. It's tracing it. So what that's really useful for is the first thing, you put a solenoid in here, it's going to be cold, and I want to warm it up. So I'm going to sit here and just let it cycle up and down, cycle up and down. Maybe I put it in here, I can do something for a couple minutes, and I come back, and now I know I've got a hot oil through there, everything's warmed up, I've got that other oil dumping on the solenoid, now I'm ready to do my test. The other thing is, though, is if I have like the Asian Warner solenoids, they have that adjustment, and they have to be brought back into, especially if you've repaired them or taken them apart or remanufactured them, they have to be brought back to a calibration. There's a calibrated curve that they have, and even if you take that a little bit away from there, adjust that away from it, it won't work in the car. They'll start throwing codes, you'll have a lot of problems. So what you can do when you have one of those is you can have this looping over and over again, and I can be adjusting and dialing that in until I get that curve that drop right back on top of my master data, and know that now I have that solenoid curve on top of my master calibrated data. So very, very useful feature for that machine. We have that same feature on our valve body tester. The advantage there is you can have the whole valve body on there. You can be doing all the solenoids at once instead of one at a time. Okay, so as promised, I'm going to stop this. I'm going to zoom the camera in on this and go through and run that one more time through all of those sequences so you can kind of get a little bit better idea of that, see it a little bit easier on the screen. Okay, and again, if there's any questions, go ahead and type them in the chat box there. I don't see we have any right now. So, and Okay, alright, so again here, first thing I did before was I did a solenoid test. And you can see here, top line here is my EPC. I have the duty cycle set at 50%. I have a 20% tolerance, so that's how close to the expected value I want the reading value to be and still say passed. So expected value is 0.93, current value is 0.97, you know, right around there, so very, very close. Obviously, if I had an open circuit, this would be reading 0. If I had, say, a shift solenoid in here instead of an EPC, this might be reading like 0.5. Tell me right away that, this isn't what I expected, so. Okay, now I'm going to go into this test scenario, and this is the pre-written script that I already have in there. I'm comparing it against the master set of data for this solenoid. I click start, and the first thing it does is pop me up and says set my test pressure. So I'm going to deadhead the machine, dial this up until I see 120 psi. Clear that, and you can see when I clear it, it drops just a little bit, not a lot. Click continue, and now it's going to do my ramp. So it's bringing my duty cycle up. You can see my current's increasing, 0.5, 0.6, 0.7, 0.8. And as that's happening, my pressure's going up also. Now it's going to hold it. Now it's going to bring it back down. So now it's going to bring my current down. So it's ramping it down. My pressure's dropping until we get back to 0. Now I've completed my test. It's going to bring my graph up. Just let me turn the current on so I can show that on the screen as well. I can even turn a legend on here so that way you can see what those readings all are. And then I'm going to just change my axis here for my current so you can see that a little bit easier. Okay, so now you can see I've got the graph on here, and the top line in gray. The dotted line is my master data for my input pressure, and the solid line is what I actually just measured. You can see they lay right on top of each other as expected. If I had a leaky solenoid and it wasn't holding that pressure back, this whole graph might be dropped down, let's say 5, 10 psi, so it'd be real obvious right away. So my output pressure is in red here, so you can see the dotted line is my master data. The solid line is the data I just collected on this solenoid. And you can see they pretty much lay over the top of each other. There will be a little bit of variation, but it shouldn't be drastic. And you can see it's nice and smooth as I ramp my current up. The pressure went up until I got to a maximum point, and it kind of leveled off, and then it came back down. In blue here is the current. This is the current the solenoid would draw as I increase my duty cycle, which is basically my voltage. You can see the dotted line here goes up, and the current lays pretty much on top of it, and I hold it, and I drop down. So you can see real easily, visually, I can see without having to do a whole lot of really thinking, the lines lay on top of each other, they smooth, they straight, you know, do I have any weirdnesses in them? Very, very easy to see what's going on with that solenoid very quickly. And I can compare that master data versus the data here. I can bring up another set of data and have 3 pieces of data on the screen at once. So I can have a master, maybe a second master, and the actual one. So I can start to really kind of compare things and kind of play with this as I really start to dig into these solenoids and understand them, and maybe some of the nuances, and you're kind of building that band of, you know, what's a good one versus a bad one. You know, these curves do shift a little bit. So I'm going to save this data. And then the last mode was the auto shift mode. That's where it's going to just ramp that over and over and over again, or go through that sequence over and over and over again. So when I hit start, you can see it's going to bring my current up like we did on that last test, and that's going to bring it down. And if I click the live view, now I can see the current as well. So I can do this, or I can bring up both graphs at the same time. So you can see I'm tracing over the top of my pressure, the red line versus the dotted line, same thing on the current down below. So again, if I wanted to adjust this solenoid, this is an adjustable pressure regulating solenoid, as I turn that dial, you'd see this graph would move either on one side or the other of that line. And I should be able to get it to fall right on top of this line unless there was an issue with that solenoid. But I can have a, you know, a calibrated curve, and I'm going to bring that solenoid back to that calibrated curve. So, all right, so let me stop that. Zoom out here. questions at all? I don't see any questions on our chat window. So anyway, that's our HT Sol 25 solenoid testing system. If you have an interest in acquiring one of these and purchasing one, reach out to me. I can get you a quote on this, lead times. We have these available. We do have a show special that will be going through Thursday, 4 days after the show, where we'll be giving one free block along with the machine. So that saves you about $320 roughly. We also have our package deal discount with our machines where you get 10% off the adapter, so 10% off any of the blocks that you buy with the machine, as opposed to if you buy them individually later on. So we have that available. If you have any other questions on any of our other equipment, whether it's our valve body test machine, our dyno, we have a dyno that we've released. We're going to make a bigger deal of it at the ATRA show if you would have been in person, but we have an electric-driven eddy current load front and rear-wheel drive dyno now available from HydraTest. We also have a complete line of torque converter rebuilding equipment, so welders, balancers, piston bonders, all the stuff you need to remanufacture and rebuild torque converters. So any of that stuff, if you're looking for, definitely reach out to us. Again, I'm Garrett. I handle the North American office, but we do have other sales guys that handle Europe, Asia, everywhere else in the world. We can get you a quote, we can get you lead times on equipment, and work with you to get the equipment you need to do the job that you need to do to build quality units and be confident in what you have going out the door. So I hope you enjoyed the ATRA show. Thanks for joining me today, and we'll see you next time.